Boiling a pot of water is not as simple as just turning on the stove. As you apply heat to the water, the temperature increases until it reaches 100 degrees Celsius, the boiling point of water. The water will stay at this temperature until all the water changes from liquid to a gas. During this process, you are continuing to add heat energy to the water, but the water temperature does not increase. Where is this energy going? The answer lies in the concept of latent heat. To understand this concept of latent heat, we must first review phase changes. Phase changes refer to a change in matter from one state to another. The most familiar phase changes are seen in the different states of water, such as freezing liquid water to create ice or boiling liquid water to create a gas. As you can tell, heat plays a major role in changing matter from one phase to another. Normally, when heat energy is added to or removed from an object, the temperature of the object changes. However, during phase changes, the temperature of an object stays constant. The temperature remains the same because energy is required for an object to change phases. Latent heat is the heat energy per mass unit required for a phase change to occur. If we think about substances at a molecular level, gaseous molecules have more vibration than liquid molecules. So when you add heat to a liquid, you are actually causing the molecules to vibrate. The latent heat is the energy required to change the molecular movement. Each substance has a unique latent heat value. The formula for latent heat is Q equals m times L. This equation relates the heat, represented by the letter Q, that must be added or removed for an object of mass, m, to change phases. The object's individual latent heat is noted by L. The unit of latent heat is joule per kilogram. The values of the latent heat are variable, depending on the nature of the phase change taking place. The latent heat of fusion is the change from liquid to solid. The latent heat of vaporization is from liquid to gas. The latent heat of sublimation is the change from solid to gas. In the previous example of boiling water, we know that we must continue to add heat energy to the water before all of the liquid water turns to steam. The latent heat of vaporization for water is 22.6 times 10 to the 5th power joules per kilogram. This means that 22.6 times 10 to the 5th power joules of heat energy must be added to turn 1 kilogram of water from liquid to gas at 100 degrees Celsius. While latent heat is not readily visible, it is the cause of many common phenomena. Latent heat is why sweating works to cool your skin. When the ambient temperature is high, your body produces precipitation on the skin. This sweat removes some of the heat from your body as it evaporates. The heat it removes is the latent heat required to change the sweat from a liquid to gas. Latent heat is also important to the creation of cumulus clouds preceding thunderstorms. As gaseous water rises in the atmosphere, it cools and condenses into a liquid. This changes from gas to liquid water releases heat from the gas. Because hot air rises, this released heat warms the cloud, causing it to rise further and thus causing more water to condense. This release of latent heat during water condensation of clouds causes the clouds to continue to grow, forming unstable thunderheads. Latent heat is a driving force for many of the common phenomena that we observe during phase changes, such as the stable temperature of boiling water. In order for matter to change phases, enough heat must be added or removed for the physical structure of the substance to change, which is the latent heat of the substance. The heat required to drive a phase change is ultimately reliant on the latent heat and the mass of the object.